is example 6. This is just making sure you remember the funky ones. Do you guys remember the funky ones?
Probably not.
So we're going to integrate x times the square root of x minus 2 dx. We're just going to make sure that we can still use u substitution to do this. So the u is going to be the inside. So what is the inside? X minus 2. Okay, what's the derivative of u? 1 dx. Okay. And then with the x, okay, so the dx, we can see, I'm going to use my marker. So I can see that this is u, and this is du, and the x in the front is something else. So what I'm going to do is I'm going to take this over here and I'm going to solve it for x. So I'm going to add 2 to the other side. It's u plus 2 equals x. And so this x is actually going to become a u plus 2. So it's like a u substitution where you're substituting in stuff for x's. Yeah. I died. I hate it when I die. Okay, so we have u plus 2 times u to the 1/2 du. What do we do from there?
You have to distribute out the...
Yeah, we have to distribute. Okay. Okay. All right, so now what do we do? Now we integrate or do the antiderivative, however you want to phrase it is fine. Okay, so, and if we remember how to do that, because we've gotten to the point officially in calculus where we've begun to mix them up a little bit. I always go back to the thing, honestly, I always go back to the derivative of x squared is 2x. Always. And then I go, okay, so don't bring the exponent to the front for integration, because that would make it wrong. So that's how I remember.
You do antiderivative.
Yeah, you add 1 to the exponent. Oh, that's it. Just integration.
A lot of times you'll ask you to integrate, and like it will have the integration sign initially. You'll have to add it.
It'll just say integrate. Yeah.
Or it'll just ask you something that you have to integrate for. But
everything else is.
Yeah, I think it's just learning those keywords. Yeah.
Yeah, once you know, like once you understand what it's used for, you can be like, oh, there's one called the monkey to use this technique, and that's neat.
Yeah, I think what I have noticed is that the instructions that tell you to take the derivative, there's like tons of them, right? Differentiate, find the slope, find the tangent line, all those things. There's not as many instructions that tell you to integrate. Like it will be like, here's the acceleration, find the velocity, and you'll go, oh, I have to go backwards, I have to integrate. So something like that where it's the context that tells you, or it will literally say integrate. Yeah.
Especially on the cheat sheets and just like on the tests and stuff, a lot of times it just asks you to, it tells you, find what the population is.
Yeah, and then you'll realize, but it's because it gave you the rate of change and you're going back to. So I think, yeah, it's either common for them to say the word integrate as in that's what you have to do, or they'll give you a context where you'll realize that you're going from a rate of change backwards. Yeah. Yeah. Okay, so 5/2 over 5/2 plus 2u to the 3/2 over 3/2.
We got 2/5.
And then. Plus C. Whew, almost killed a hedgehog. That was a close one.
What if I want to distribute the numbers beforehand?
I mean, I just want to make sure we're good. U to the 5 halves. What happens when I flip up the 2/3? Or the 3 halves? So 4/3, 2 times 2/3 is 4/3. Okay. And then
We substitute back in x, and x times 2.
what a fun problem. So the question this unit always becomes, because this is integration techniques, that's the unit that we're on now. So in the past, our integration techniques have been recognize that you can just take the antiderivative of it because it's in the right form, or do U substitution, right? That's the only techniques we've had so far. Yeah, that's true. Yeah, so we had to recognize if it was in that fraction form so it like matched the yellow sheet. That's true. And now we're going to start to add more things where it's going to be like, Ms. Rice, how do I know what I'm doing? At this point, it's recognition. It's like pattern recognition, okay? These are the ones that typically throw me off a little bit because they don't feel like U substitution when you get started. And then you go like, oh, it's one of the weird ones. So I call these U substitution the weird ones. And it's my like, oh, I think that might work. I don't know. Okay. So when you're going through this unit and you're like, oh, this is frustrating, how do I know which one to do? The answer is practice more. And then you'll get to the point where you start to like recognize it and almost like develop a sixth sense. And you'll be like, oh, I think that's how you do this one. Okay. So this is not the unit to not finish your homework or classwork or practice. This is the unit where we do all the problems because we need all the practice we can get. Okay. The next one is going to be to integrate x times 4x minus 5 to the 9th dx.
I wonder which one could be the inside.
That's crazy, right? So u is
4x minus 5.
du is
4. 4, yeah.
I don't see a 4 hanging out.
We gotta do, it's all for you, and divide by 4.
So 1/4 du equals dx. Okay. So this is a u. This is a 1/4 du.
We can bring that 1/4.
Yep, we can take that, move it to the front. So right now I've got 1/4 in the front, and I've got a u to the 9th and a du, and I just have to know what to do with that x. Okay, so plus 5, u plus 5 equals 4x, u plus 5 over 4 equals x, so that's cool. So that x is actually u plus 5 over 4. So we have a u plus 5 over 4, a u to the 9th.
Where did you get u plus 5 equals 4x?
So all I did is I took this and I added the 5 over.
Okay.
Yeah, I went from here over to here and then I went down.
No, you have to divide that by 4 again. So that's peachy.
Yeah, so what I might do is take the 1/4 here and the 1/4 there and make it 1/16 in the front. Are you guys cool with that?
Please do it. That way we don't have to multiply you by 4.
Okay, so then that's what we have. Cool? Okay. So now what do I have?
U plus 5 times u to the 9th. And then distribute u to the 9th. Get u to the 10th. Plus 5 times 5 u to the 9th.
These are some very unfun.
Just to the 176.
No, it's 1 over 176, which is still nasty.
Yeah, u to the 11th over 10 plus.
U to the 11th over 10.
Oh, wait, no, I don't know why I said 10. Plus 5 u to the 10th over 10. That's what I said.
Wait,
Whew, save that hedgehog. We love the hedgehog. No need for it to die.
Let me just turn that to use
What's 16 times 11?
170. Wait.
Why do you guys always go to telling yourself you're stupid? You're like, I made a slight mistake. I have no intelligence. It's like, no.
I made a simple error.
Your brain farted. That's all that happened. You just
I
went.
brought this on
And
to
then it
my
was,
family.
Sudoku is the only option.
oh, I went to box this answer. Goodness gracious. Almost killed a unicorn. You could write 16 times 11, that's fine.
Could we factor it out on the
Yep. Look at you looking for that factor by grouping. I like. That was nice. That was a nice touch. Yeah.
C ruins everything.
Always. Okay. Really dumb, but I liked it. That made me laugh sincerely.